In this video, we're going to review some calculus AB concepts about motion along a line. And whenever we talk about motion in calculus, the ideas are always based on the basic relationship between position, velocity, and acceleration. And if we are moving down this list, that means that we're taking a derivative. If we are moving up this list, then we need to be using integrals. That's how we move between these different concepts. An important thing to remember about velocity is that it does have a sign. Can be positive or negative, but the sign indicates direction. Sometimes we'll be asked questions about speed. We need to remember that speed is the absolute value of velocity. Speed is velocity without direction. There's some different concepts dealing with a position that we need to kind of keep clear. At its most basic level, position is an integral of velocity or an expression that involves an integral of velocity. However, if I have the integral from a to b of velocity dt, if I just have that integral, this is going to give me what we call displacement, or it's just the change in position. It only tells me how much the position has changed from time A to time B. If I want an actual position at B, then what I have to know, if I'm going to find out something more than displacement, I have to know a starting position. And so I need to know the position at A, and then I can add to that the displacement, and that'll give me the position at B. So position at A plus the displacement, or the integral from A to B of v of t dt. This gives me position at B. And a final expression involving an integral of velocity is this one, integral from A to B of the absolute value of velocity, or really the absolute value of speed. And what this does, by doing absolute value, it takes all the movement in the negative direction and makes it all positive, so that when we add together all of the movement, we get total distance traveled. Total distance traveled over that time interval. There are some important vocabulary words that have to do with velocity that we need to be clear about whenever we are asked a question about a particle being at rest. That means that our velocity is equal to 0. If our particle is moving right, if we're moving back and forth on a horizontal line, or up, if we're moving back and forth on a vertical line, that's going to mean that your velocity is greater than 0. And if we're moving left on a horizontal line or down on a vertical line, that means that our velocity is less than 0. Sometimes we are asked to find average velocity, and in this case, it's going to be really important for us to pay attention to what function or information that we have in order to be able to find average velocity. If I want average velocity and I am given information about the position, then what I'm looking for here is an average rate of change. And so we, of course, would do x of b minus x of a over b minus a if our position function was x, movement along the x-axis. However, if I'm asked for average velocity and I'm given a velocity function, average velocity, and I'm given velocity, this is asking me for average value because it's asking me to average the thing that I have. And so in that case, we're going to use the formula 1 over b minus a, integral from a to b, v of t dt, which, if you think about it, is actually equal to the formula that we have above, because if I do integrate velocity from a to b, it gives me the position at b minus the position at a, which would be x of b minus x of a. And then we divide by b minus a. And so really these are the same formula. It just depends on what information we have as to how we're going to find these things. And finally, sometimes we're asked if the particle is speeding up or if the speed is increasing or if it's speeding down or decreasing. If the particle is speeding up, that means that v of t and a of t, the velocity and the acceleration, have the same sign. That means that they are working together in the same direction, either both working in the positive direction or both working in the negative direction. That's what causes a particle to speed up. If the particle is slowing down or speed is decreasing, that means that velocity and acceleration have different signs. And anytime you're going to justify anything about speed increasing or decreasing, you have to find both velocity and acceleration. Okay, so that brings us to the end of kind of the vocabulary of motion, the rules of motion that we need to be able to refer to. Let's look at some examples. In this first example, we're going to use this data that's given in this table to do 3 different things with it. The data in the table below represents selected values for the velocity in feet per second of a particle moving along the x-axis. And the velocity v of t is a differentiable function of time t. And then we have that data given there in the table. And our first question at time t equals 0, is the particle moving to the left or to the right? Explain your answer. So at time t equals 0, we can see v of 0 is equal to -4. And since this is negative, since v of 0 is less than 0, that tells me that my particle is moving in the negative direction. And in this case, we're moving on the x-axis, and so the particle is moving to the left. And to explain our answer, all we need is this statement here, that the velocity that we're looking at is less than 0. Let's look at another question here. Same data table here. Is there a time during the time interval 0 to 10 when the particle is at rest? Explain your answer. Now, this question starts out with, is there a time? Hopefully you remember that signaling use of a theorem. It's either going to be intermediate value theorem or mean value theorem. We want to know when the particle is at rest. If the particle is at rest, that means that v of t equals 0. And that's what we want. That's what we want to know. Is there a time when v of t equals 0? Well, if I look at the data in my table, I can see that here I have a negative value at t equals 3, and then at t equals 5, we're at a positive value. And since my function is differentiable, I know it's continuous, and therefore sometime between 3 and 5, the velocity would have to be 0. So we're going to say yes. Since v of t is differentiable, it is continuous. I'm going to abbreviate that too. And IVT applies. It's always best to start out stating the condition that it has to be continuous and naming the theorem that we're using, which is intermediate value theorem, because 0 is in between -1 and 4. There is a time t. I'm going to say between 3 and 5 when velocity is equal to 0, because v of 3, whoops, I put t, sorry, I meant 3. V of 3 is equal to -1, which is less than 0, which is less than 4, and that is equal to v of 5. Okay, last question for this set of data. Use 4 trapezoids as indicated by the data in the table to approximate the integral from 0 to 10 v of t dt and explain the meaning of your answer. All right, so first of all, let's go ahead and work on this approximation. I'm going to mark off my 4 intervals and determine the height of each one. Remember that the height is the delta x. Notice all of my heights are different, so it's important that we pay attention to that. Integral from 0 to 10 v of t dt is approximately. So my first trapezoid is going to be 1/2 base 1 plus base 2 times the height of 3. So 1/2 -4 plus -1 or -1 times 3 plus 1/2 times my 2 bases on the next interval, -1 and 4, -1 plus 4 times the height, which is 2, plus 1/2 times the bases on the next interval are 4 and 7, and the height is 4. And for my last trapezoid, the bases are 7 and 11, and the height is 1. And remember, there's no need to find out what that's equal to. We can just leave it in that form. Now explain the meaning of your answer. This goes back to those different expressions that I gave you for integrals of velocity. If I am just integrating velocity from 0 to 10, this is only giving me a change in displacement, a change in position, which is displacement. So this is the displacement, or you could say change in position of the particle. And remember, we are explaining the answer, the meaning, so we need to woo-woo. This is what it is. The units would be in feet, and the when is from t equals 0 seconds to t equals 10 seconds. Okay, we're going to consider this scenario. For t between 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equal to cosine of pi over 6t. The particle is at position x equals -2 at time t equals 0. And for 0 less than or equal to t less than or equal to 12, when is the particle moving to the left? So again, moving to the left, this means that v of t is less than 0. That's what we're looking for. In the problem, the function that we're given is v of t, cosine pi over 6t. So we're going to set this equal to 0. And so now we're asking ourselves, when is cosine equal to 0? Well, that of course happens at pi over 2, 3 pi over 2, and we may need to continue going on, 5 pi over 2, 7 pi over 2, and so on. So this whole expression, pi over 6t, is our angle. So if pi over 6t is equal to pi over 2, that's going to make our velocity be equal to 0. And so if I multiply both sides by 6 over pi, then I get t is equal to 3. Now remember, in our problem, t is just between 0 and 12. So we want to make sure we get all the values between 0 and 12. So I'm going to say this is also going to be equal to 0. Cosine of pi over 6t is going to equal 0 whenever that input pi over 6t is equal to 3 pi over 2. Again, let's multiply by the reciprocal. And let's see, I get 18 divided by 2, t equals 9. And let's just check one more just to be sure. The next one would be at 5 pi over 2. And if I multiply, I'm kind of out of room here on the side of my paper, 6 over pi. If I do that, that's 30 divided by 4. Oh, wait, not 4, 2. silly. Don't know why I wrote 4. 5 pi over 2, so I get 30 over 2. That one gives me t equals 15, and that's out of our interval. So these are my only two times where the velocity is equal to 0. Now, the reason I found those is because now we're going to do a little sign chart and see where this is positive and where it's negative. So if I pick a number over here between 0 and 3, like 1, and plug it in for t, that just makes this pi over 6, and cosine of pi over 6 would be positive. If I pick a number between 3 and 6, you could pick 4, you could pick 8. I'm going to pick 6 just because that makes it easy, because then my 6's divide out, and cosine of pi I know is negative. And between 9 and 12, there's not a super convenient one. We could pick 10, which would be 5/3 pi, and that would be positive. 5/3 pi is in quadrant 4, where cosine is positive again. And so the only time this particle is moving to the left is when it's negative, which is between 3 and 9. So, but we need to answer the question. The particle is moving left for 3 less than t less than 9 because v of t is less than 0 on that interval. Oops, sorry. There we go. Now you can see the rest of it. Particle is moving left for t between 3 and 9 because v of t is less than 0 on that interval. All right, let's look at the next question. Write, but do not evaluate, favorite words in a free response question. An integral expression that gives the total distance traveled by the particle from time t equals 0 to t equals 4. Now remember, total distance traveled, what that means is that we want to take all the negative velocities, or the times when the particle's moving in the negative direction, we want to make them positive. So we do that by absolute value of velocity, or finding the speed. This is the speed, and we're going to sum up all of the speeds from 0 to 4. That gives you total distance traveled. It's all we have to do on that question. All right, next up, find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. So to find acceleration, we know that's the derivative of velocity, which is what we were given in the problem. V of t is equal to cosine of pi over 6t. So first thing, let's find acceleration. That's going to be v prime of t, which is equal to, I've got to do a chain rule here. So the derivative of cosine is negative sine of pi over 6t times the derivative of pi over 6t, which would be pi over 6. So that's the first part of the question. We have the acceleration at time t. Now we need to know, is the speed increasing, decreasing, or neither at t equals 4? So remember, for speed increasing or decreasing, we need both velocity and acceleration. We have to find both. So velocity at 4 is cosine of pi over 6 times 4, which is cosine of 2 pi over 3 if we reduce that 4 over 6. And we could find the exact value, but really all that matters here is if it's positive or negative. 2 pi over 3 is in quadrant 2, and I know cosine is negative, and so that's less than 0. The acceleration at 4 is going to be equal to negative sine of pi over 6 times 4 times pi over 6, which is negative sine of 2 pi over 3 times pi over 6. So sine of 2 pi over 3, that's in quadrant 2. Sine is positive, but then this is making it negative. Multiplying by pi over 6 is not going to change the sign. And so this is going to be less than 0 also. Again, the value doesn't matter. It's just the sign that matters. Since they are both negative, therefore, the speed is increasing because V of 4 and A of 4 are both negative. Or you could say both have the same sign, are both less than 0, any of those things. Last question here. Find the position of the particle at time t equals 4. All right, so we are starting out at velocity. I know that in order to get to position, I need to integrate velocity. But if I just integrate velocity, that only gives me displacement. I need to be able to add to this a position that I know. So let's go back to the prompt. Let me share the prompt again here. The last thing that they told us in the prompt is the particle is at position x equals -2 at time t equals 0. So that means I know x of 0. I'm going to start my integral at 0, and I'm going to stop my integral at the time that we're interested in, which is 4. This is going to give me x of 4. Okay, so my position at 0 is -2 plus the integral from 0 to 4 cosine pi over 6t dt, which is equal to -2 plus the integral of cosine is going to be sine, but notice we need to, this is like a u sub. Our u would be pi over 6t. The du would be pi over 6. So I'm going to need to multiply by 6 over pi. Have that multiplying by the reciprocal sine of pi over 6t from 0 to 4. Should probably put that in parentheses because the 0 to 4 is only for this part. It's not for the -2. Then -2 plus 6 over pi times sine of pi over 6 times 4 minus 6 over pi times sine of pi over 6 times 0. And on a free response question, once we've plugged in the numbers, we can leave the answer just like that.